This is another network of resistors containing two parallel sections of resistors and one resistor connected in series. Before we move into details around this, first of all, let us once again remind ourselves that feel free to drop your topic in any science subjects for me to teach. In so doing, I will equally encourage you to promote this channel by subscribing, all right? Sharing with your networks, your students, with your friends. Also give us some thumbs up, right? And then put on the bell button for post notification each time content like these are uploaded. Let's move into it. Today we are going to see how we are going to solve this and then arrive at the answer in a very unique way. Alright, so let's pick our ball pen. Now the first thing we need to understand here is that there are two sections. Section A contains two resistors connected in parallel. Section B contains three resistors connected in parallel, right? So we have two sections, A and B. So first of all, what we need to do here is to solve and then get the total resistance in section A, right? Then after which we solve to get the total resistance in section B and then add the two alongside the only one resistor connected in series. That is what we are going to do here. By the time we do so, we will arrive at the total resistance offered in the electric circuits of this kind. So section A is going to be 1, the formula is 1 all over R subscript T, right? And this will give us is equal to 1 over R1 because we have only two resistors connected in series plus, right? 1 again, I'm solving it in real time over R2. So this one represents the number of resistors, okay, excuse me, the number of resistors connected in the first section here. Look at it, okay, 1 and 2. So we have two resistors connected in section A parallel, okay. So if we substitute, we have here 1 over R1. R1 is 2, so we put 2, right? Then we substitute again plus 1 over R2 is 1. So that's very simple. So by the time we do the needful here, we will find out that we will just have 2 times 1. There's another way to calculate this. 2 times 1, right? All over 2 plus 1, okay? If we do this, we have 2 plus 1 plus 1, okay? And this will totally give us, let's see, we are going to have 2 times 1 is 2, right? Good. Then 2 plus 1 is 3. All right, so that is it. So we have 2 plus 1 is 3. All right, good. If we put this in decimal, we are going to have 0 point, let's see, 0 point, because 3 divide 2 cannot, we put point and then add 0 here, it becomes 20. 3 divides 20 is going to give 6, all right, 6 and then 7 approximately. So this should be the answer for that. If not, and it's measured in ohms, okay, our unit is ohms. Good. So that's the total resistance offered in the section A by the resistors connected in parallel, right, in section A. Now, having found that, we move on to section B, where we have 3 resistors offering resistances 3 ohm, 5 ohms, and 4 ohms respectively, connected in parallel. So we're going to solve that at section B and then see what we're going to arrive at. So section B, we need to solve to find the total resistance in section B. Here we have how many resistors? 3. So it's going to be 1 all over RT, okay? The total resistance we are looking for is equal to, we are going to get about 1 all over R1, okay? That's good. Then we move on again. I have plus 1 all over R2. I am solving this in real time, right? R2 representing resistor 2. Then plus 1, because we have 3 resistors in that section. 1 all over R3 representing resistor 3. Good. So we have identified, we have clearly stated the formula we are going to use. The next thing we need to do here is to substitute accordingly. For 1 all over R1, we are going to substitute 3, right? Okay, let's see how it works. Yes, good. Then the next one, we are going to substitute for 1 all over R2, we are going to substitute 1 over 5. 1 all over 5. Good. So we've done that. The next one is going to be 1 over R3 representing 1 all over 4. 1 all over 4. Great. So we have succeeded in substituting all the numbers in section B of resistors connected in series. Good. We have done that. If you have watched up to this moment and you have found pleasure, you have found value in watching this, in learning this, it is time for you to support me by subscribing, share with your friends, share with your networks, share with your colleagues, share with your students, share with any family you know that needs something like this. All right? And then put on the bell button on for constant notification each time content like this is uploaded. If there is a willing heart to learn, there is also a passionate and willing teacher to teach. All right? Take it from me. So we continue from there. Then what do? We have successfully substituted accordingly, okay, in our section B. So we need to find the LCM. The LCM here, 3, 4, 5 or 3, 5, 4. What 3? The number that 3 can divide, no remainder. 5 can divide it, no remainder. And also 4 can divide it, no remainder. So that's what it means. And that number is likely to be what? It's going to be 60. Yes, 60. We use our 60. Yes, 60 can go for this. All right? Good. So if we have that, now 3 divided 60 is going to be 20. 20 times 1, look at it. 3 divided 60, we get 20. And then 20 multiplied by this one remains 20. So we write 20 here. We are going to economize this space. We have 20. All right, good. And we put our plus sign quickly. Then 3 divided 60. Rather, okay, 3 has gone. Let's look at 5. 5 divided 60 is going to get 12. All right, 5 will get 12. And what that means is that 12 multiplied by 1 is going to give us 12 again, so there's no need. So we have 12. All right, so we put our plus sign. We will continue to manage this space until everyone is contained. 4 divide 60. Good. 4 divide 60 will get 15 each. Each of them will get 15, 15, 15, 15 by 4. That will give us 60. So 15 times 1, I repeat, 15 multiplied by this one, we still remain 15. So we find a way to squeeze it here to avoid wasting space. All right. Okay. Just bear with us. Good. So we have 20 plus 12 plus 15. So the answer is going to be, we have 1 all over, we have 1 all over ROT subscript, right? Our ROT here is going to be such, we will understand that ROT here will give us what we need, and the ROT is 20 plus 12 is 32. 32 plus 15 is going to give us 47. 47 all over 60. Good. 47 all over 60. Real-time solution. 60. Good. It's like my 60 is not good looking. Let me just do something to make sure. Okay, so let's see. All right, so we go back again, rewrite our 60 is 60. Good, we are getting it now. Perfect. So we have 47 all over 60. What do we do? Because we need to make ROT the subject. We multiply both sides by inverse. We multiply both sides by what? Inverse. We come here again, inverse. This side, inverse. Good. So we are going to put inverse here. Okay, and then we come to this point, put inverse. Good. So with this, we are doing what we are supposed to do. This inverse we take care of 1 over, and we are left with just let's see, we are taking this right. Okay, we are left with just ROT. Okay, RT. Good. And then equal to, so what happens? This inverse, what is going to do is to invert. Okay, it's going to invert this. 60 will go up and the 47 will come down. So we have 60 will go up or come up, right? Good. And then 47 will come down. That is it. Now we have succeeded. We have succeeded in finding the total resistance in what? In the section B, connected of resistors, right? Good. So what is remaining now is for us to look for a way and find the entire total resistance in the circuit. All right, and that has to do with connecting this, adding it to this, and then adding to this. Okay, so the total resistance in the circuit can be solved as simple as that. So let's see how it works with this. Now what do? We are going to start from here and write ROT. ROT is our total resistance. I want everything to be on this page, so ROT is going to be our total resistance offered in the entire circuit. This time around we are going to add 4 ohm, right? We have 4 plus the second section here, the section A is 2 over 3, excuse me, 2 over 3. All right, good. We have 2 all over 3. Good. Then the section B, total resistance here, as we calculated, is 60 all over 47. All right, so we have 60. All right, all over 47. Good. So that is it, 47. All right, so by the time we simplify, all right, so to make this to look the same with others, we are going to introduce all over 1. All of them now are in the same fractional standard, right? So what we're going to do here is to find the LCM once again, but the LCM here is 47, right? That is it. We are going to use 47 to multiply everything here. We are going to use 47 to multiply everything. So 47 multiplies 4. What is it going to give us is something we need to take note of. Then 47 multiplied by 2. Okay, what happens? And then 47 multiply here is going to cancel out. So we need to understand that. All right, good. So that's what we're going to do in a very clear terms. By the time we do that, we will arrive at a very concrete answer, and that becomes our final answer. I'm going to leave that for your own. Resolve it. Tell me what the answer is, and the unit is going to be in ohms. Alright? Yes, I want you to do that. Tell me what the answer is, put it in the comment box, resolve it, and then tell me what the total resistance in this whole circuit is all about. I have done almost everything, but I want you to help me find the total answer following the steps I have outlined, right? If you get the answer, drop it in the comment section. Thank you for watching up to this moment. I must commend you. It's not easy to sit down and learn, but learning is a continuous process that deserves some amount of patience. All right? Once again, I thank you so much. Don't forget to subscribe. Give us some thumbs up. Come on, come on. If you have watched this and you found value in it, learning pleasure gained, give us some thumbs up. Share with your friends, share with your networks, share with your students, share with any family member that needs something like this for their children, and so on and so forth. Just promote this channel, right? Thank you so much. Don't forget to give us this thumbs up. All right? Thumbs up. And then turn on your bell button for constant notification each time something like this is uploaded. See you in my next class.